Imagine a bridge. A bridge isn't just a single line, it's made of multiple beams, each one supporting the structure in its own way. When all the beams work together, the bridge becomes strong and stable. But if even one beam is out of place, the whole bridge becomes unstable. Now, picture the beams as different waves, each with its own frequency or wavelength. When they combine, like the beams in the bridge, they create a wave packet, a stable, localized structure that can travel across space, just like how a bridge lets you cross from one side to the other. The waves support each other, and when they're in sync, they form a stable packet that moves as one. So, why does understanding wave packets matter? Well, they're not just any waves. These packets reveal one of the most profound and mysterious aspects of reality, the relationship between waves and particles. This is where quantum mechanics comes in. In the quantum world, particles like electrons aren't just tiny little balls. They can behave both like particles and like waves, and that's where wave packets come into play. When we look at a particle, what we're actually seeing is a wave packet that represents all the possible places it could be. The center of the packet is where the particle is most likely to be found, but it's spread out, indicating uncertainty about its exact location. This uncertainty is key. You see, quantum mechanics challenges our classical understanding of the world. In the everyday world, we can usually pinpoint the position and speed of something. But in quantum mechanics, the Heisenberg uncertainty principle says we can never fully know both the exact position and momentum of a particle at the same time. The wave packet helps illustrate this principle. As it spreads out, it shows that the particle isn't just in one place, it's spread out over a region. The wider the wave packet, the more uncertain the particle's location is. But when we try to pin down where the particle is, the wave packet collapses into a specific point. It's this strange behavior that lies at the heart of quantum mechanics. The true magic of wave packets shows up when we consider superposition, the idea that a particle can exist in multiple states at once. Imagine a light beam traveling through two slits, creating an interference pattern behind it. This pattern shows that the light behaves like a wave, but when we look closely, the light decides where to go, acting as a particle instead. Wave packets help us understand this dual nature, that particles can exist in multiple states at once. This is known as wave-particle duality. This is why quantum mechanics is not about certainty, it's about probabilities and understanding the likelihood of events. Understanding wave packets helps us grasp the uncertainty, the probabilities, and the dual nature of particles in the quantum world. It's the foundation for so much of the cutting-edge science that shapes our understanding of reality.